Hello, this is Miss Nakayama again, and today's lesson is 5.5b. Emma, don't make fun of my B. Inverse of a function. Now, functions that undo each other, we've kind of talked about this as the year has progressed, that undo each other are called inverse functions. And the graph of an inverse function is a reflection of the original function over the line y equals x. So to find the inverse of a function algebraically, we're going to switch x and y and then solve for y. And we've kind of talked about this with our graphs a lot. This is the key right here. You just got to remember to switch your x and your y. So the first example we have, find the inverse of f of x equals negative 4/5 x plus 16. So remember, f of x is the same thing as y. So when I switch these things, I'm going to get x equals negative 4/5 y plus 16. And I'm going to solve it for y. So I'm going to subtract 16. And then I'm going to multiply by the reciprocal of this coefficient. Y'all say divide by negative 4/5. We say multiply by negative 5/4, because that means it looks like that when you do it, and then you just distribute it. And the last thing you do before you distribute it, or you distribute negative 5/4 x, and then negative 5/4 times negative 16 is plus 20, and we replace it with the notation. And we've talked about this before. That notation right there, f inverse of x, is negative 5/4 x plus 20. All right, another one. Find the inverse of this linear function. Again, switch x and y. First thing, always switch the x and y. So I'm going to have x equals 3y minus 1. I'm going to add 1, and then I'm going to divide by 3. And I'll tell you that you don't need to make it, okay, there we go. You divide by 3, you don't make it difficult. You can leave it like that. There's nothing that says you can't leave it like that. So f inverse of x is x plus 1 divided by 3. Now, those were linear functions. These two were both linear because there's no exponent. Now we're going to do one that is quadratic. And they tell us find the inverse of f of x equal to x squared. If x is greater than or equal to 0, then graph its function, the function and its inverse. So we start off by switching x and y. So I'm going to have x equals y squared. Then I'm going to take the square root of both sides. And you need to remember that when you take the square root, that means that this technically is plus or minus the square root of x is equal to y. But they told us in the beginning that x had to be greater than 0. So if x has to be greater than 0, then on the inverse, y has to be greater than 0. So that means I only want the positive part of the graph, and that would be positive square root of x. Now, to graph it, y'all pick whichever one's easier. Okay, I hope you all know how to graph this one. F of x is x squared. Okay, those are the key points we've talked about often. Okay, 1, 2, 3, 1, 4, 9. To find the inverse, all you have to do is switch the points. So this is the inverse, and this is what the graph will look like. And if you had a nice little, if I was good, I would have drawn the line y equals x, and you can see that that's symmetric. So the green one is my original function, f of x equals x squared, but it's only for x greater than or equal to 0. And then there is my square root function. All right, what if it's a cubic? Okay, so f of x equals the quantity of x plus 4 to the 1/3. Find f inverse of x. So again, I'm switching my x and my y. And we talked about this earlier this week. We have raised to the 1/3 power. I'm going to multiply by the reciprocal of that, which is 3. So I'm going to raise both sides to the 3rd power. So that's going to give me x cubed equals y plus 4. I'm solving for y, so I'm going to subtract 4. And using my notation, f inverse equals x cubed minus 4. Now, to graph them, which one is easier for you to graph? Do you know what this looks like, or do you know what that looks like? Okay, so do the one that you know how it looks like. Okay, you know that this particular function, our cubic function, is that little, however you want to call it, snake-looking thing, curvy-looking thing. Okay, we know that it's been shifted down 4 units. And the key points that we should be familiar with, it usually is at 0, 0, but that's going to be shifted down. And then we just do a rate of change with the other points. Well, if you know that, Then when you go up here to x plus 4 to the 1/3, it's just going to be these points flipped. I didn't want to do that yet. Pooh Bear. I didn't want to. All right. So I was actually trying to get to these points here. Okay. So all I did was take this and flip it. Okay. And you know the starting point's not 0, 0 because that 4 on the inside shifts the function to the left 4 units. So now we aren't required to show you. You didn't have to graph it, but I just wanted to show it to you. Okay. The blue one, I went down 4 units and then I did my key points 1, 1, 2, 8 and the other way. And then same thing here. I went left 4 and then went over 1, up 1, 2, and 8. So again, symmetric around the line, y equals x. They were supposed to intersect at that point. Okay, let's talk about a radical function. Find the inverse of a radical. Consider the function f of x equals 2 times the square root of x minus 3. Determine whether the inverse of f is a function. Okay, and way back in the beginning when we talked about what a function was, I mentioned to y'all the vertical line test tells you whether or not something's a function. The horizontal line test tells you whether or not it's 1-to-1. Okay, so if I know that the function is 1-to-1, then that means its inverse will be a function. So if you can remember that, this particular function, 2 times the square root of x minus 3, passes our horizontal line test because it's just that swoop like we just graphed up here. That's the radical function right there with some transformations. It passes the horizontal line test. Therefore, the inverse of f is a function. So then we have to go find the inverse. So again, we switch the x and the y. And you can divide by 2. Either way, you got to remember to square the 2. But to get rid of my radical, I'm going to square both sides. So I have x squared equals 4 times that thing in parentheses because that radical is going to go away when I square it. Okay, this is all multiplication. I got to square the 2 and I got to square that thing. All right, then I'm going to divide by 4. And I'm going to have 1/4 x squared equals y minus 3. And so then I'm going to add 3 to it and put it back with my f inverse notation. 1/4 x squared plus 3. All right, now 2 functions. We got 2 more examples and we're done. 2 functions, f and g, are inverses if and only if both of their compositions are the identity function. So that says if f of g of x equals x and g of f of x equals x. Okay, so the identity function, in case you don't remember, is that function y equals x. So we have to verify functions are inverses. Verifying in math, y'all, is the same thing as doing proofs. Okay, so this is, if you're verifying, you know what the answer is when you do f of g of x and g of f of x. What are you going to get as an answer? X. But it's a proof. And if you don't show me enough work in the proof, you will not get full credit. So that's the important part of it. You can't just skip from the beginning to the end and go, well, it all works out. You got to show me the steps. So the first one, f of g of x, is f of what? F of 3x minus, or f of g. G, my bad, is x plus 1 over 3. Okay? And then f says 3 times whatever you have in parentheses minus 1. Well, what's in parentheses is x plus 1. And then I'm going to simplify the 3's. That gives me x plus 1 minus 1, which becomes x. So those are the steps that I need to see when you show me these things. Now let's do g of f of x. That's g of, what's on the f of x? F of x is 3x minus 1. And so what does g say? G says whatever you have in parentheses, add 1 to it and then divide by 3. So in my parentheses is 3x minus 1. And this time I'm going to simplify my numerator. 3x minus 1 plus 1 is 3x over 3. And then I simplify. So that are the steps that you have to show me. You cannot just jump from here to here. I need to see some intermediate step of things working out. All right, one last one. Verify these 2. This is example 7. Verify that f of x and g of x are inverse functions. So again, I'm doing f of x, f of g of x. G of x is that radical, so that's f of that radical. And f says 2 times whatever you have in parentheses, okay? So whenever you're doing this step, wherever you have a variable, you put the parentheses. What goes in the parentheses is my square root of x plus 1 over 2. Again, when you square it, what do you get? So my next step is that, because squaring it removes the radical. Then my 2's cancel out, so I have x plus 1 minus 1, which leaves me with x. All right, and on the last one, g of f of x, that's g of, what's f of x? F of x is 2x squared minus 1. And g says, this is my rule for g, it says, so I'm going to go plug in for that x up there. So I'm going to have a radical and parentheses where the x goes. And what goes in the parentheses is f, which was 2x squared minus 1. And how does that simplify? Well, the top simplifies first, so you should show me the square root of 2x squared over 2. Then my 2's cancel to the square root of x squared, and then I have x. So I have verified and proven and shown all the work to support it. So that is all for inverses of functions. Thank you so much for watching, and y'all have a great